Right, this part we're going to focus on today is making the cap that screws into the top of the spout. This is a cap here. It has most of the dimensions on this particular view, but it doesn't show you what diameter material we're starting with until you come across and have a look over here, which says diameter 16. So the part we're focusing on is this piece here, the cap on the end, which is threaded M10, has a metric diameter 10 thread on it. It has a seal, a rubber seal, which we'll need to stamp out with some hole punches, and it is knurled, which provides a finger grip so you can tighten it up. The knurling pattern is a diamond pattern around there. We have a number of pieces of equipment we can use. We definitely need to use the odd leg calipers. We definitely need a marker pen to mark so that we can see the scratch the odd legs make. We need to use the die. This is a die and the die stock, and we need a steel rule as well. However, we can progress, depending on what stage you're up to on using measuring equipment. We can use these vernier calipers, which could replace the outside calipers here for measuring outside diameter. They can also be used for measuring inside diameter across the points, and also the depth of a hole at this end. But with this particular piece we're making, which is the cap on the end of the brass ornamental flask, we're mainly interested in measuring outside diameters accurately. As always with a piece of material, we need to start by facing the end off, by moving the cross slide hand wheel nice and slowly, creating a nice finish. If you find that the tool looks like it is rubbing as opposed to cutting, then make sure you see me and have the tool sharpened. We do need a keen, sharp tool for cutting brass. Steel is not quite as fussy, but brass is. There we go, beautiful finish on the end. Now this piece of brass at the moment is diameter 20, and we need to reduce it down to diameter 16. So I'm going to set my odd leg calipers on 16 millimeters, like so. Now what that means is I can start measuring while I'm machining. Now the cap is just under 20 millimeters long, so that's about how far I need to go along to machine. Now, I could have marked off that length for the odd leg calipers, but we're not down to the size that I want to do precision measuring to, so it's not going to matter a whole lot. Here we go, 20 millimeters. Now I'm going to do a trial cut on the end and take it down to 16. Just check that with the lathe stopped. Nice, just a little bit of resistance there. Perfect. Now I'm going to machine across at that measurement, which is the size I want. always take care with the final cut, move the carriage along really nice and slowly and evenly. Don't let the tool stop. If the tool stops, it tends to leave a ridge. The tool tends to cut a little bit deeper if the tool is not moving at a consistent rate across the work. That rate of movement across the work is called the feed of the tool. There we go. There we go. A beautifully finished piece of brass. Now it is the length I need, a bit more than the length I need, and it's now reduced from 20mm down to 16. Right, now I'm going to set my odd leg calipers on the measurements for the cap here. So we've got an 8mm, then we've got a 3mm, then we've got a 6mm for the end piece which is knurled. And so I'm going to use my odd leg calipers, set off my steel rule. You're familiar with that now from the work we've already done. Alright, so on goes the ink. The total length of this is 17mm. I don't need to put the ink all the way around, just on one part of it. Odd leg set on 17mm. Alright, I can see quite clearly the scratch mark in the ink. Now I'm going to move the calipers along again. I'll just change the angle of the focus of this so you can see a bit clearer. Maybe just zoom in a bit. Okay, so the mark that I've just put on is right there, and then I'm going to put some other marks on here which match up with these marks here. So we've got an 8mm here, and then we've got a 3 and then a 6. And as we machine it, we're going to machine it that way, starting from this end. Yep, so that one of the last things we'll do is knurl it and then part it off from the stock, which is protruding from the lathe. So if I hold that like that, that's pretty much the way we're going to machine it. We're going to machine down to the diameter 10, which is the thread size, for that distance of 8mm. So there we can see the 3 marks. The first mark is 8mm, so this first little bit there is 8mm, the next part is 3, and the last part is 6. It's quite small, you probably can't see that. Alright, so we're looking at, from there to the first mark is 8, then it's 3 between those 2 marks, and then 6 in that part. That is the part we're going to knurl. That is a part we're going to create, we're going to neck the material. In other words, we're going to create a groove which is deeper than the thread, and this part here we're going to thread. Now this part we're going to machine down, in fact all the way up to that second line we'll machine down to diameter 10, and then we'll thread it. Now I've just machined this piece down to 10mm, ready to take a thread, and now I have rotated the tool, and if I bring that around so you can see what's going on here, zoom it back out again. I've positioned the tool so that the side face of the tool is then going to bevel the edge of this. Now that's quite important for using a die, because the die does not like cutting straight into a square piece of metal shaft or metal rod, so we need that lead in to support it. And so I'm going to use that tool there. I think you can see the angle better in the background, about a 45-degree angle bevel on that. We just need to make sure that we can rotate the chuck and not have anything foul in here, because sometimes you're concentrating so hard it's very easy to damage the lathe. So I'm just going to machine that in now. There we go, done. Now we're going to set up the lathe to use the die. And so that's this thing here. We need to take that, and we're going to place that onto our work, and then we're going to support it with the tailstock, but we need to remove the centre out of the tailstock. We're not going to use that centre at all. So remove that, eject that, wind it back until it ejects, like that, take that out, and we're just going to use the front of the tailstock spindle here to push on the die to keep the die nice and square. Right, now we've got the die supported by the tailstock spindle. It's pushing on the flat part of the button die in here. Yeah. The other side of the die inside here has a tapered teeth, which will start the threading process. And what we're going to do is rotate the chuck until this rests on a part of the carriage here and not causing any harm. And then while we rotate the chuck here by hand, we are then going to feed this hand wheel in just so that it applies a little bit of pressure as we go. Alright, here we go. Tailstock is locked with this hand lever here. The chuck is ready to move. I'm going to apply a little bit of pressure with my right hand on the hand wheel as I rotate the chuck, and you'll hear it starting to cut. Now I'm not forcing it on with the tailstock spindle here. I'm just applying enough pressure so that this stays nice and square. And as with all machining of brass and thread and cutting of brass, we do not need a cutting lubricant. Although when you've done threading in the past on steel, you would have used a lubricant. All right, now that's pulled on enough, so I don't need that on there anymore. So I'm now going to rotate that, and I'm going to go backwards a little bit, and then forwards again. When I go backwards, it's going to cut off that swath. All right, and we're just going to keep going until you feel a definite resistance, which means it is coming up against the other end. Now at no point do we want this die stock to be touching the bedways down here, because these bedways, they determine the quality of the machine. In other words, if they're damaged, then your lathe will not be as accurate as it would have been when it was new. Alright, here we go. We are there. And as you can see, the thread has started. We're going to turn the die over, and we're going to use the reverse side, because the reverse side has got the finished size on it of the thread. And so by doing that, we're going to finish the thread as far as we possibly can with this tool, forwards and backwards. Imagine if the lathe was turned on, you could end up with a real mess, couldn't you? Nice and slowly. There we go. Beautiful. Now we have a finished thread. It's finished as far as we can make it anyway, because you'll see the thread is not quite finished at the left hand end. And so what we're going to do is take the parting tool in there, the width of the parting tool, and we're just going to go down below the bottom of the thread. The bottom of the thread is called the root. The tips of the thread are called the crests of the thread. Oh, something I have forgotten to mention, and that is that when we're using the parting tool, which is the tool I've got in there at the moment, somewhere in there, yeah, this tool here, because it has a flat end on it, presents quite a lot of surface area to the work, and so we need to halve our lathe speed. So our lathe speed at the moment is 790 revs per minute. We're going to pretty much halve that, and so we'll go down to 380. No, it's not exactly half, and that is going to be the speed which is going to be much more suitable for using the parting tool, which is what I'm going to do now. We change those speeds Let's go over that again. So we were on 790, now we're going to go to 380, which means these two controls have to tilt to the right. 790 is there when this one tilts to the left. So now you need to wiggle the chuck while you're changing gear, because the gears are spur gears, in other words they're square cut gears, and they don't like changing gear without the chuck moving a little bit by your hand. Alright, in we go. Yeah, nice and slowly, just so the tool doesn't bog down. Make sure you go below the root of the thread. There we go. Finished. Now the final thing we need to do is to use a knurling tool and create a knurling pattern on here. Right, so we're going to remove the parting tool, putting the knurling tool back in the rack in the correct place. Now before we clamp a tool in the tool post here, make sure it's always really well swept, because we don't want to be clamping our tool onto a piece of swarth material. Just means it affects precision, it also damages the tool, can damage the tool post as well. Now you'll see some dents in the top of this along here. That's because previous people have over tightened the knurling tool. Tools don't need to be really winched down humongously tight, just firm. Twisting these bolts here just with one hand pressure like that is plenty. Now when you set the knurling tool up, it needs to be at right angles to the centre line of the lathe. Yeah, and we're going to set the lathe on the slowest speed, which here is 64 RPM, so the tool has got a chance to do what it needs to do without damaging it or overheating it. So let's just do that now. Alright, what we're going to do is simply take the tool straight into the work until we have an impression. So basically we need to just get in, get it done, and then get out again. Push quite hard, quite firm until you end up with a finished diamond pattern like that, and then out again. And that creates the crisscross knurling pattern, which is going to be the thumb grip. Right, next thing is to start parting that off. So we're going to start parting it off here, but we're not going to go all the way through. We're going to go kind of like maybe a quarter of the way through, and then we're going to swing the turning tool around, and we're going to take off all of the sharp corners here, here, and here on the edge of the thread, and then we have a finished product. Now because the knurling obscures some of the marking out, this end piece was 6mm long, and so I'm going to use the steel rule looking straight down on top of it, and I'm going to set that on 6mm. 6mm right there, and that means when I use the parting tool now, we'll leave it on the same slow speed, we'll take that parting tool in, I'll increase that speed a little bit. What we want 380, don't we? 380. Nice and slowly, nice and slowly. Just so your metal cutting off. Don't let the tool rub. Alright, I'm going to withdraw that tool now, and I'm going to swing the tool post around. Swing it around so that I can then use this tool here to take off any sharp edges, any of the burrs. Right, let's do that. Swing my tool post around. Position the tool lock it. Alright, this is now set up. Once again, once you're this close, and the clearance is between the tool post, the top slide and the carriage, when they get quite close like this, just really keep an eye on it. Just make sure you have got enough room to move. So what I'm going to do now, I'm in position. Now I'm going to move the carriage to the right to bevel that off. Like that. Withdraw the tool. Do the same on the other side of the knurled nut piece. Like that. And then on the end of the thread, the same treatment. Like that. And that's pretty much finished. We just need to part that off. And parting off we go. I need to adjust my parting tool height. We have a little bit left in the middle.